Yeah. Anyone wants to read? Okay. I mean, anyone wants to go, or shall I start to read?
I think you can go
Okay.
because I'm outside right now.
Okay.
But I can do the reading tomorrow for sure. Yeah.
Yeah, sure. So the first section that we are going to read is prioritizing advantages. So, okay, I'm trying to understand what is the prioritizing advantages, but we will go through which of the discussed reasons for switching to microservice is the most important depends on the individual scenario. So they are saying like why we are moving towards microservices kind of an individual scenario. The use of microservices in a greenfield system is the one exception. I'm not sure is what does that greenfield system means. I think it's kind of a idea that they're explaining. More often, a deployment monolithic is replaced by a microservice system. In that case, different advantages are relevant. So yeah, I mean, they're kind of what is the advantage? So main thing is the scaling of development. So the easier scaling of development can be an important reason for the introduction of microservices in such a scenario, which is thinking from the development standpoint, instead of multiple developers working on one code base, mono repos kind of approach. This is kind of a multiple repository we can keep in a GitHub, right? Like we can have each microservice be sitting in a different repository so that each individual team can work on it. That's the advantage I see. Like often it is impossible to work quickly enough with a large number of developers on a single deployment monolithic. Yeah. So it's so hard to have like one monolithic code base having multiple developers working on that. The second point is the easy migration. So still there, we are coming back and kind of giving it's giving a sum up of what is the real advantage, the ease of migration away from the legacy deployment monolithic facilities, the introduction of microservices in such a scenario. So in case, if you really wanted to migrate, if our code base is very small and if it deals with only one responsibility things, then it's so easy to migrate. That's the one advantage of having microservices. The other one is the continuous delivery. So continuous delivery is often an additional goal. The aim is to increase the speed and reliability with which changes can be brought into production. Yeah. So here, since the repository is very small and they're saying like it can be more speed and reliable. The scaling of development is not the only scenario for a migration. For example, when a single Scrum team wants to implement a system with microservices, scaling development would not be a sensible reason since the organization of development is not too large enough for this. However, other reasons are possible. Here they are saying is like, I mean, scaling development would not be a sensible reason. Okay, I mean, that is not the only reason, but there are other advantages. Other reasons are possible. Example, like a continuous delivery, technical reasons like robustness, independent scaling, free technology choice. Yeah, pretty much what we read in the previous section, they are kind of summarizing. In the end, it is important to focus on increasing the business value, depending on a scenario. An advantage in one of the previously mentioned areas might make the company more profitable or competitive. For example, faster time to market or better reliability of the system. Yeah. So instead of going more technical things, but here they are saying is like we need to have to kind of think about the trade-offs. Anything wanted to add, like, I mean, is that really adding a business value? That's what they really wanted to look at it. I mean, are we going to gain anything, or is that really bringing dollars, right? That's the whole thing that we need to look at. The same time, we are trying to move monolithic to microservice based. So that's what I think we are going to kind of review in the later section to see what are all the different trade-offs that we need to think about it. Anything anyone wants to add here?
I guess that straightforward, right?
Sorry.
I mean, you
Okay.
mean to say other than whatever mentioned on top of that, or like I think that's very straightforward one. Whatever.
Yeah, yeah, yeah. There are like, I mean, as when we read through that, there are like 7 or 8 reasons that just we could think of. But here they are saying like, don't try to put all these things in the microservice reason, but think about, is that really, each point, is that really adding a business value? I mean, that's where like somewhere I read like, not all monolithic can be converted to microservices. So we really need to add in based on the team, based on like, is that the company is a small company or a big company, and do we have that many resources, like all things, is that really adding a business value? All those things, that's what they are explaining it here.
Yeah. Then on top of that, if the service or application, which is more like each service is more kind of not so much interacting each other, that way also we can think microservice, right?
Yes.
So I guess in teams, they see the business value of doing anything. Sometimes the kind of development works, it needs to migrate a service, or the development the labor that needs to be put into doing some kind of automation or stuff is more than the advantage that it might make. So I guess that is one of the things they also look at it.
Yeah, 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 agree with you.
So not
And
every good thing, not every productive thing it makes a business sense. There are, I guess, as Deva mentioned, there are some use cases in e-commerce kind of applications where breaking down everything into microservices might not be a good idea, because that might add to lot of hassle of lot of development hours to put into, rather than going for a ready-made solution, or some microservices like a monolithic solution, something like
yeah,
Sometimes you may not see immediate short-term benefits. So like it may look for the business that you're spending a lot this year, but the trade-offs, I mean, the benefits will maybe more long-term, right?
that. Yes,
For
totally.
yeah.
Yeah. Yeah, I guess it should be both ways. Yeah, I guess I just wanted to say that there could be some reasons where it is not a good idea to convert it into microservices. Only that sort, that example I was giving.
Yeah.
okay. So yeah, so moving forward, microservices involve trade-offs. So that's the thing that we are going to review. Depending on the aims, a team can compromise when implementing microservices. For example, when robustness is the goal of introducing microservices, the microservices have to be implemented as separate Docker containers. Yeah. So the scalability or robustness is the goal, then they are saying that microservices have to be implemented as a separate Docker container. So each Docker can crash without affecting the other ones. So can crash without affecting the other ones. Yeah, that's the, so if they are saying is like, based on what is our business aim, like, if it's a robustness is the main goal, then we need to take a decision, technical decision based on that. If robustness does not matter, other alternatives can be considered. For example, multiple microservices can run together as a Java web application in one Java application server. In this case, they all run in one process and therefore are not isolated in respect to robustness. Still, they are independently deployable. A memory leak in any microservices will cause them all to fail because all of them are running under one process, right? However, such a solution is easier to operate and therefore might be the better trade-off in the end. Yeah. Yeah, I would, in our side, like, the same thing. Right now, we are not to the Docker yet. We are still kind of running all the, but we still go with like, separate uh, microservices kind of thing, but we are putting it in application servers. Anyone wants to, yeah, this is the trade-off that they are saying. Anyone wants to add any points, like, this is one of the sample or any other things to add?
Deva, one doubt here. So I'm slightly new to this memory leak concept. So memory leak in any microservices. So how in a production server or in a service, how exactly this issue occurs?
Oh yeah, I mean, I dealt with like multiple leak issues in the sense like what happens is like sometimes, I mean, nowadays we have like all the JPAs or cleaner things in place, but this can happen anything if the connections are not properly handled or any such memory leak issues happen. Usually we say heap size. I mean, we set a heap memory, right? We say that based on we put like in like each infrastructure based on that for every server level, we put a heap, maximum heap that it can run, like 12 GB or 24 GB based on that. So if we are not cleaning up all the usages properly, then what it does is like the Java heaps keep on growing, and then it can bring down the whole the process itself. Which means, let's say I have a web application. Sorry, I have an application server. Let's say WebLogic is running, and I could run multiple microservices into that. And let's say one microservice is taking more heap, then that will bring down the whole WebLogic, because WebLogic will, I mean, any application servers will got into some kind of stuck threads, and then it may max out the heap, and then the server will crash, and then the server will not respond. So we need to take all the heaps and then find it out what was the root cause. The advantage of choosing the Docker is like, each Docker container is going to have their own application servers and then their own application JVM, and then that's where like the microservice is going to work. So each pod will have their own container, their own JVM environment, and then that's where the Tomcat or like any application service is going to run, or web application server is going to run. That's where the microservice is going to be deployed, right? If so one goes down, we can auto scale up or something, we can do it, but this needs a lot of extra work. We need to have a separate DevOps team to handle the container. If the team is very small, let's say there is no DevOps team or something, then it's better to go this approach. And moreover, the scalability, right? Let's say our application is used by only 10,000 people or 20,000. It's better to go with the web application more, because we need not to be that much scalable. But if we have like a bigger applications, like there are so many millions kind of people are using, then we need to think about this approach based on like what is our user base, and depends on.
Makes sense. So and so is it a typical reason could be something like tangling pointers, zombie processes, or some constructor destructor issues, something like that, or are there any other reasons for memory leaks as well?
I've seen like, mostly I've seen like in microservices, I've never seen that problem, but we have like very old applications, kind of not a JNDI or JDBC based. We kind of go and create our own connections, and we kind of go and close the connections. That's where I've seen a lot of memory issues came up.
Yeah, mostly
But
unmanaged code. So if you
exactly.
have managed technology like Java or C Sharp, that's fine. But if you're using C++ or C, these are unmanaged. Give a lot of power to you to manage the memory, but at the same time they don't close. Once you use an object, you're supposed to dispose it. So if the disposing is not happening, then that will lead to memory leak. So mostly depends on the technology, right? Like if you have even a third party package that you use, if it's unmanaged code, then there's a chance of memory leak.
Got it.
Yeah. I just kind of pointed maybe most of like connection, database connection based, but it can happen any level also. If it's not managed well, then it can cause that memory leak.
Got it. So in terms of connections, you meant to say JDBC connection, right? Loose connections.
Yes, that is one from the database perspective. But I'm trying to think: is there anything can happen from the, like, not IO related? Anything can happen um, from the Java object itself. Sometimes, it can happen like, if you're using just a string, and let's say you are processing a bigger file, And like, you can keep on loading things into the string, and after a certain time, it goes into a memory issue. So that's where like, we need to think, we need to think correctly, like, what is our feed file? Just one sample, like it did not to be always database, like any logic that we are writing, we need to think like what is the max it could come, what are the objects are we really using, is that really, are we releasing those objects, is that really garbage collected, are we sanitizing properly, or all those things that we need to make sure. Nowadays that there are try with resources like that all are in place, which means JVM itself can take care of a couple of cleanups and other things. But I think that developer should know that, like, are we really following all those things? That's where all the best practice comes in picture. So if somebody is not properly peer reviewing, and if it goes to prod, then QA also, because if all the processes are followed, then this can be mitigated, but it can happen in production if the code is not properly reviewed or managed well.
So one question I was asking the team where I was working, right? We have a microservices architecture, Docker containers, everything. But the question I was asking was like, the same example you gave, Deva, right? Like, let's say you are creating a string and then keep on adding data, and let's say, like you do several such things because of the calls, API calls, and let's say you fill up the whole heap, whatever, right?
Yeah.
When you are deployed on a cloud, the system is supposed to automatically scale up, right? Because when you set your goals for for automatically scaling up, meaning like creating newer instances, you would say like, hey, once my memory is like 90% full or whatever, then deploy another instance, whatever, right? But I was told that that's also actually a setting, and or whatever agreement you have with the cloud provider, and unfortunately that was not implemented in our company where I was working. So even if you
because
have
that there is a fee involved into it. That's the challenge. Like, if let's say we need to bring up a new EC2 instance, it can add up a lot of depends on what EC2 instance and what power. We added part of the template, right? Let's say we want to bring it up a new EC2. Usually we create a template and we say, hey, this is my RAM and all those things. I've seen that could be the reason, but this will give us a small window. The real reason is like, let's say we are auto scaling one more, but if that server goes down, we really wanted to bring up a new one quickly as soon as possible so that the application can be up. But eventually the real solution is we need to find out what was the root cause so that we can avoid this. But if it's really because of the scalability, really users are using that much, and then that's a different story. Then we need to see long term how many. So we may need to scalable. We need to increase the instance in such a way. But if it's because of the memory leak, then we need to find out the root cause to get that resolved.
Yeah, I think you need to figure it out sooner than later, I think.
Yeah.
And I guess GC metrics are also quite one of the most used metrics, right? When something crashes, I guess now I know that, like, why they go to GC metrics mostly.
Yeah. And moreover, one more thing, after Java 8, I think Java 9, they have so many new garbage collectors were introduced, but I'm not sure much in detail, but those are all really good in cleaning up all those things. And they are saying like some kind of a cooling time, or because the garbage, when the garbage collection happens, it will not allow, or the system will not process much because it's doing the other work, right? So I've read somewhere like they are adding. They have added so many garbage collectors recently. So it's kind of a different side, but there are architects, those who try to change different garbage collector based on the type of applications. If it's really business critical, they can play around with the different garbage collectors to see is that really helping, like that. And the benchmarking also very important. Yeah.
Cool.
Yeah. So, okay, to move forward, like 2 levels of microservices, domain and technical. Oh, okay. The technical and organizational advantage points to 2 levels at which a system can be divided into microservices. So here they are, the microservices itself, we are dividing into 2. One is domain and the technical based. a coarse-grained division by domains, enables the team to develop largely independently and and allows them to roll out a new feature with the deployment of a single microservices if it concerns just this one domain, as it usually does. However, sometimes multiple domains are involved and more than one microservices must be deployed. Yeah, basically they are kind of giving like a domain or a module kind of thing. So the first approach is like you go by domain, which means divide microservices based on the domain. That's a domain, which means like, business boundary or however we are. For example, in an e-commerce system, customer registration and the order process can be examples of such coarse-grained microservices. So user registration, which is a user-based one that we are dividing. The other one is a order process. So that is one kind of a module or one domain that we can split up. Then that is a business-based or domain-based. So here, the other way of splitting or other way of thinking about the microservices, for technical reasons, some microservices can be further divided. So they are saying that I thought it's kind of fully business-based, but I think we can divide microservices for technical reason also. These microservices can then be scaled independently of the other microservices. So for example, the last step of the order process is under especially high load, this last step can be implemented in a separate microservices. The microservices belongs to the domain of the order process, but for technical reason, it is implemented as a separate microservices. This is an example of a technical division. So here we can see, these are all in one microservice, which is full text search, category-based search, and search. So here it's not kind of a domain or search kind of an idea. And then checkout, they're making it as a separate, payment is a separate microservice, and delivery is a separate microservices. So the drawing above shows an example of two levels based on the domain. So I see that checkout, payment, and delivery is domain. Let's find it out. Yeah, so based on the domains, and e-commerce application is divided into microservices. So one is the context is search here, and then checkout, and then the payment and the delivery. So now if you see that the search itself is kind of chunked into multiple microservices based on some technical reason. So the search is divided, is further subdivided. The full text search is separated from the category-based search. So yeah, so here we are going with the two different microservices. One is for full text search, the other one is the category-based search. So independent scaling can be one reason for this. This architecture allows the system to scale them full text search independently of the category-based search, which is advantageous when both have to deal with the different levels of load. Another reason could be the use of different technologies. Okay, the full text search can be implemented with a full text search engine, which is unsuitable for the category-based search. Yeah, it's kind of a NoSQL based, or this one is kind of RDBMS based search kind of thing. So they're giving like why we are splitting based on technical reason. Typical numbers of microservices in a system. It is difficult to state a typical number of microservices per system. Based on the divisions discussed in this chapter, 10 to 20 coarse-grained domains are usually defined, and each of these might be subdivided into 1 or 3 microservices. However, there are always systems with far more microservices. Yeah. Anyone wants to add here? I understood that there is no tight information that it should be domain or it should be technical. They are kind of giving to the architects or who are designing. You just need to take the context of that and think about it, whether it is the best way to think about split it as a logical, and then deeper inside, do we need to split further? It's fully depends on the architects or whoever is designing that system.
Is anybody use the search with these two type microservices?
Oh yeah, we can do that. Because this is a NoSQL bus, right? Like free text search, there is a Lucene or some products available, which is an elastic search based, right? So they can define a separate microservice. I think any free text search, that's how but I've never seen, I've never looked at the code implemented, but I have an idea that any free text search, they do kind of an elastic based search. And if it's a proper categorized search, then we can directly go and look into the RDBMS table itself. So
Yeah.
then there they can use a category based search.
Okay.
I guess in elastic searching, the idea is about mapping, right? So they cache the data beforehand and they keep some mapping between terms to a data point, right? And that's how they try to initiate the full text search within like with a good performance, right?
Yeah, yeah. I'm not 100% sure, like, how the inner work of Elasticsearch. Anyone?
Okay. So I just wanted to ask if you are aware about like the latency part of search, like what is the difference between the Elasticsearch latency and any random category based search?
Okay. My idea is like, but I may have to, my thought process is like, Elasticsearch is kind of a text search, which is like a NoSQL search, which means it's going to find it out from non-structured data. But I'm not sure, like, how it's maybe it is, I'm not sure, like, so that anyone can search anything. So basically it is going to go and find it out from the non-structured database and see if it is available or not. But I'm not 100% sure.
So does it mean like it can be like in a document DB?
Yeah, it's a kind of a NoSQL
Oh,
approach.
NoSQL. Oh, okay,
Yeah.
okay.
But I think that Elasticsearch system, it's just the same way, but uh, there is a
Okay, so while using Elasticsearch, we don't need to do anything, right? It's just like abstracted by Elasticsearch themselves. We don't need
yeah.
to do anything about search. We just delegate the task for Elasticsearch, right?
Yeah, this product empowers, we need to see how this product is done, but the whole idea, I think, this product helps us, like, so for example, this Elk is also one of the, like, right now, one more challenge with the, one more drawback of microservices, right? You may have a one monolithic application which gives you one log file, right? But now you are breaking it up one monolithic into 10 different microservices. So all different 10 microservices are 10 different applications. So all 10 different will give you 10 different log files. So this is one of the things that we follow, which is nothing but elastic based. We use like Elk Stack. So what it does is like we kind of three different product involved, but what basically under the hood it does is like it just reads all 5 or 6 different log files, and then it just displays that in console. So you can go and filter it out, or however you wanted to find the content, you can find it. Let's say something got crashed and we wanted to find it out in what order, when it crashed, and all those things. But the idea here is like we have that flat file is there, and the stack is looking into that, and internally it does all those things. It reads the text file and it gives or projected in the UI in a way that you can search and find it out, or you can go, there are some dashboards available. But the idea is like this tool is helping us to read it from the text based and then for a quicker search. So it's not kind of we are going in a RDBMS based, because that's where the whole challenge. If we have more than million record, then RDBMS slows things down. But not the other way. If it's a NoSQL, then definitely we have faster result.
This is what Splunk does as well, right? Even Splunk takes all the log files and produces
Yes.
information.
Yeah. Splunk is a commercial product, but this is an open source.
Mhm.
So this is about so you're talking about Elasticsearch.
Yeah, I think we started from here, but somewhere we moved to the discussion came up like,
Yeah.
kind of from full text search.
Yeah,
Okay.
so I guess I have seen this use case of full text search in like say in some cases. So I was just curious like how they are doing this full text search. So I just wanted to know if it is like Elasticsearch take care of that, or do we need to implement any system to perform that full text search, because searching is perceived as a very costly operation, right? So I was just trying to understand it from that perspective.
So I don't know about the Elasticsearch. I don't know if it is same thing, but definitely what this is search and searching the full text. So basically, what happens? Let's say what I have seen is, let's say you have 10 microservices running, and like each of them have like couple of pods, uh, and you need to aggregate the logs, like where all the panic or errors are happening, right? So you need to look in the logs of all those files, right?
Yeah.
So we have, in AWS we have some, I don't know if it's part of AWS or not. I think we have something called as Loki. So it just accumulate all, it searches all the logs for all the microservices, all the pods, and segregates, and also you can get the UI form of visualization for that. So that does the text search, the Loki, if you want to
Okay.
LOKI. Yeah. Yeah, see, it is product of AWS. Yeah.
Okay. Okay.
And then they can display those logs. Let's say you have, you found some error, right? Let's say you have your service is doing throwing some errors, and you find 100 instance of that. Then by the count, it can show you on the Grafana charts.
Mhm. Yeah.
So what's the difference between Loki and Grafana? Grafana is more after it mines all the logs, or
No, Grafana is
So
just the UI.
Grafana is just
Sorry,
the
go ahead.
UI, but the search is being done by the Loki. Loki is the engine.
oh, okay, okay, got it. Thank you.
Yeah,
Yeah, I've
Grafana is
seen.
dashboards.
Yeah, just to add in one more thing that I've seen in like I mean the current the Kubernetes or that one also, like they are using like Prometheus, or that is also kind of a,
Yeah,
and then
yeah, yeah,
Grafana kind of
yeah, yeah. So, so I have used both actually. I have used Prometheus. I mean, and the Loki. So Prometheus is also another kind of library. I have used it for both the deployment and the cron jobs both. But it just works a little differently for both of them. What Prometheus does is just it collects some metrics, and Prometheus server should be listening to those, and then it omits out those into one of the servers where they can be aggregated, and then Grafana helps to visualize those Prometheus metrics.
okay.
Yeah.
Yeah. Okay. Yeah. So to move forward, the idea here is like, I mean, kind of a summary is like, I mean, we can split microservices in any way, and then we need to think about the trade-offs. That's the whole outline, what we learned from here. It need not to be like, domain-based, or it need not to be technical-based. Anything, we just need to understand the context, and based on that, we can think about splitting that. So are we good to move to the next one, or based on timing? We are
Did
good,
we
right?
look at that quiz question? There
Oh,
was.
yeah, we can definitely. Okay. So a division by domain always results in a deployment of a single microservices for a change in the system.
False, right? Because the domain here is also subdivided based on
Oh,
technology.
yeah, that's correct. Suppose you are designing a small social network and you come up with a domain-based microservice to search for which of the following are plausible technical divisions of this. I've got some reminders for Gorica. Search through all friends, search through all members, search photo albums, posts, or search text posts, create posts, delete posts. Here they're saying a small social network. With the domain based, which access to search posts.
I guess B, right?
Search photo album posts. Why we need to
It's a
have a micro?
social network, right? Social network come up with the domain-based microservices in search posts. So social network generally what we search.
Yeah, I think the question is how would you divide the domain? So they're saying it's a small social network, which means the members are small. So you don't need to divide it by friends, members, blah blah.
Okay.
By posts. So now the other way of dividing it is by
Yeah, post
posts. So search photo album post, search text post might be a good one. Yeah, I agree with the
Yeah.
B.
Yeah, I too agree with that because creating the post, searching the post would be the complicated one, right? I think there would be so many posts could come. Yeah. To make microservices independently deployable, they must first be divided into Docker containers.
True. No?
No, no,
not
because it can be deployed separately, right?
Independently deployable. For one deployment, you go by with one Docker container, right?
Yeah, but here say, I mean, to make microservices independently deployable, they must first be divided into Docker containers. But without
no,
Docker itself, I can deploy, right?
yeah.
Okay. I
So
don't, I'm not, yeah, you may be right. I'm not sure.
Why? What is
uh,
the?
here, the, here the question is, to make microservices independently deployable, they must first be divided into Docker containers.
Meaning, like, let's say you have two services, right? And you want both of them to be independently deployable. So they should be going two different Docker containers.
Yeah, but
I don't have too
considering,
much knowledge on Docker containers, so I'm not entirely sure. Maybe someone who's more familiar can answer that
I
one.
think here the Docker container is like creating the image of each service, right? Like or each deployment.
yes, but it need not to be. It need not to be a Docker container itself. Let's say I have two microservices. I can put it in two different application servers, right? Here they are stressing that it should be a Docker container. That's what I feel false. But I'm also not sure, like what exactly they're expecting from this question.
Yeah, anyone can have the like a combination. Even
Let's try false and see what it
Okay.
says. Oh, okay,
Yeah.
yeah, right. Okay. They don't need to be divided into Docker containers.
Yeah. I mean, without Docker itself, we can still have a microservices deployed in two different application servers.
Okay, but will they need a container if not Docker? Um, if not the Docker technology, like in Amazon Cloud, let's say it's Azure.
Yeah.
Okay. Yeah,
Uh,
yeah, I think I understood. That's fine. We can move on.
okay. Here, I mean, here they are forcing us that it can be any cloud provider, like any GCP or AWS. But here they are forcing us, saying that if you really wanted to independently deploy the microservices, you should use Docker containers. That's
Oh,
what I feel, failure. I
it's
mean,
false.
right now we are moving towards Dockers, but there are so many companies without using the container approach, they still deploy microservices and follow the regular pattern of deploying the microservices in the web application directly in the VM itself.
Okay, okay, got it. Okay, yeah,
Yeah,
that makes sense. Yeah.
yeah. So in the next session, sorry, in the next lesson, we'll look at some challenges that the microservice architecture poses. So that's where I think we are going to. Are we good to move forward to? I mean, yeah. Some of the challenges. I mean, what are all the cons that we see from microservices?
I think we can finish this chapter, I guess. Like
Okay. Okay. Then I'll move forward. Like in this lesson, we'll look at possible challenges involved in a microservices. Yeah, this is also one important interview questions. Like most of the cases, like, they can ask pros and cons. That's a thing that, or like when we individually design the system, also we can think about these approaches. The first one is increased operation cost, definitely, right? So the operation of a microservices system requires more effort than running a deployment monolith. This is due to the fact that in a microservice system, many more deployable units exist that all have to be deployed and monitored. This is feasible only when the operation is largely automated and the correct functioning of the microservices is guaranteed via appropriate monitoring. Yeah, anyone wants to add in? This is very clearly saying, right, and now we are chunking it up, like, so we have so many logs, so we need to have a lot of automation, at the same time CI/CD also, because we split it into multiple applications, so everything should be deployed properly, and individually that needs to be deployed, right? I mean, instead of one application deployment, now we split that into 10.
Yeah, there's a lot of automation that is required for deployment as well as for monitoring after you deploy, post-deployment monitoring, and then there should be DevOps, which should be periodically checking at the reports or any issues come up. They have
Yeah.
to escalate, make alert the dev team or support team.
Yeah. And one challenge I've seen, like, if it's a monolithic, like, we have one log, always so easy to go and find out what is the issue in that log file. But there are other, the elk stack and all helps, but we need to have like other, because let's say the transactions, sometimes, we start with the user based and then it go and hit on multiple microservices to get the response. So let's say if some microservice failed, we need to know the whole transaction idea. Okay, it started from this microservices and then the input went into this one, then it passed to this one. That's where it ended up in issue. So we need to have some kind of a collective microservice idea. So to find the root cause for that issue. That takes some time, but there are other tools like, elk tools and all available, so that it can give us the whole core structure of, how that error occurred and the whole flow. We will be able to track.
Yeah, tracking will take time if there's an issue. Like usually we have something like a coordination ID. So you start with one service and dig into the logs, and if you get the coordination ID, then you have to go search the logs of another service with that coordination ID and other services. So you have to, it is complicated digging through the logs.
Okay. So just to move forward, so the first one is like, operation effort. The second one is must be independently deployable. Microservices have to be independently deployable. For example, dividing them into Docker containers is a prerequisite for this, but it is not enough on its own. Changes to interfaces must be implemented in such a way that an independent deployment of individual microservices is still possible. For example, the microservices which implements the interface has to offer the new and the old interface. Then this microservices can be deployed without requiring that the calling microservices be deployed at the same time. Here, are they talking about the contract must be independently deployable?
Yeah, here they are saying like, so let's say interface, by interface they usually mean like a UI interface. If you can imagine a UI interface which is calling the old version of the microservice, and now you're deploying a new microservice. So you need to make sure for a while both of them are supported, because you might the UI may have already deployed some. I mean, this is all about at the time of deployment, right? So the old one is still holding up, and the UI may be talking to the old microservice, and then now you've deployed the new one. So suddenly if you bring down the old one, then the UI will fail. So that's what they mean here. You need to support both of them for some time.
Okay.
Also here I want to ask a question. Like what technology are you using guys, like in your companies for deployments?
We use Jenkins. I mean, the other company, I mean, other team members, but from my side, we use kind of Jenkins, and that's where we kind of a webhook or once the applications move to a specific layer. I mean, if it's committed or we kind of follow some Git flow workflow kind of approach, which is we create an appropriate feature branch that got meshed. I mean, each company follows a different approach, so we kind of connected a Git with Jenkins. So if is pushed to a specific, if any commits push to a develop line, then automatically that will kick in some process, and then automatically it will get deployed into that respective service. We don't
Yeah.
have like, but there are other I mean, each company goes in a different way.
Yeah, we use Git too. We use Git and a combination of which creates like under the hood it creates the Docker container and deploys it. So
Okay.
I was just curious what other companies are using.
Okay. Yeah. Any other ones? Anyone wants to add in? Any different approach? There are so many CI/CD.
Yeah, for example, I don't know what's used for AWS.
Yeah, AWS also. I mean, Aditya wants to add in, like, they have like code. They have their own like a CI/CD pipeline, some kind of a build tool like that. I mean, when I was reading for AWS certification, I read through, but practically, I'm not sure. Like, anyone wants who are using AWS want to add in?
They do have their own, but unfortunately, for the cost saving purpose, we are not using them. We're just trying to use whatever is required. Like, for example, even like we don't use even like uh, I mean, on a different topic like API gateway as well. We just configure our own Nginx. So we, just for the sake of cost optimization, we are using we're not we are just using the Jenkins in short, but they do have something similar in their as their product.
Okay.
Okay, cool.
Okay. So just to move forward, the third challenge, the testing must be independent, which is a good thing, but I see here we have a challenge also. Yeah. Also, test must be independent. When all microservices have to be tested together, one microservice can block the test stage and prevent the deployment of the other microservices, making testing much harder. Due to the split into microservices, there are more interfaces to test it, and testing has to be independent for both sides of the interface. Yeah. So we used to kind of, that's where like, I mean, I've seen, I mean, practically, if anybody wants to add in, like previously what we do, one team just works both UI and the backend kind of thing. But nowadays, like we have like an API contract, which is a backend team. So that's supposed to be tested separately. And the UI team creates the UI that will be separated testly. And then there is some integration also, like how we are integrating. Then there's a separate UI testing. The integration testing also comes in picture. So I'm seeing like, it involved more effort or doubling the effort of API testing separately, and then the whole UI, I mean, connected with the UI testing.
Yeah,
I think that's,
I've also seen this. We have like a lot of unit tests before you deploy. You're supposed to write and make sure all of them work, and then you have these integration tests. And after that, finally, the UI has to test the contract. Only after they approve, we deploy to prod. So,
okay. One quick question, like let's say a backend team is working on the API contract, right? Is that needs to be, I mean, I'm trying to find out, is that will be deployed? I mean, is that section will be deployed, I mean, tested by the QA team? And then the whole UI after integrated with the UI, then also there's a testing involved, or the backend is just the unit testing just to make sure, all the unit testing is covered. So the QA team works only on the full testing. They are not working on it. Is that the way that your team works, or the QA team involved in API testing, and then they work on the UI testing also?
It depends. They will
It
do
depends.
sometimes the backend testing and the UI also. So if the time is already UI is there, or if your migration projects, then they go on more UI. Sometimes they just want to test the connectivity between the services. Then they go on the backend.
Okay.
But
So they
mostly
were
UI testing is the last answer, like everything to go good kind of thing will be done by UI.
Okay.
Yeah, so they were. I think this is very, kind of subjective and independent. I mean, company specific, uh,
Uh-huh.
because everywhere they try to adopt whatever they need. But like from my experience, I'm mostly working on a backend side, so like whatever we develop, we commit, right. So with every commit, uh, they have I mean, of course they have a configuration file in the Jenkins where they say when the commit is done, then these are the unit test cases and the different other kind of test cases, like, which also includes code coverage as well. So there are
Mhm.
certain categories of tests which run, and for every commit. And so that's for the backend. And once the front end is ready, and basically once you do the complete testing, then that is understood. Like, of course the backend is already ready, so backend is included as a part of complete testing, then that automatically redoes the same test with the full end to end.
Okay.
There might
Okay.
be possibility, right? There were one microservice may not have the UI only.
Right. So they might be talking to each other, and then the front end or the complete end to end might be talking to different services as and when required, right. so
Mhm.
so two aspects is, one is like, of course, at the microservice level, of course. So so basically, like, let's say I have microservice A. Whenever I do a build, it all, as a part of the build, it also runs the test case also, because that's what we have, and that's how we have configured. It will run the build, and it will run the test cases also, which are the like unit test cases. And
Yeah.
only once that unit test cases have passed, then we will do the push and run on the
Yeah.
Docker push and Docker run. So
Okay.
yeah, that's the kind of normal builds, run, push and run. But when you have done all those things, and when we do the commit, then there are additional tests which are being triggered by the Jenkins.
Okay. Okay. Yeah. Yeah. So yeah, that's where I've seen, like, the effort is, which is one approach is like, but in our side right now, we are not, I mean, we write still, we kind of go with the the unit testing. So when we fire that Maven build package, it automatically builds, but at the same time, as part of the life cycle, it runs the test cases also. But one thing, I mean, even though we write a JUnit and have a coverage of 90%, but what we do, we still pass it to the QA team to make sure kind of a functional testing, and there is an automated testing cases also, kind of, so that in future they can kind of write automated way. But that is a separate the QA team work, but that involved more effort, because previously we used to kind of, everything is monolithic and very simple testing. The QA is involved only once, but here they involved twice, because they are going to separately test I mean, that's how right now, but I'm trying to get an idea, how overall we are following or something like that, just to add in. Okay, so this one we already checked, and the next one is like difficult to change multiple microservices. Difficult to change multiple microservices. Changes that affect multiple microservices are more difficult to implement. Yeah, okay. Then the changes that concern several modules of a deployment monolith. Okay, in a microservice system, such changes require several deployments. These deployments must be coordinated. In the case of deployment monolithic, only one deployment would be necessary. Yeah. Anyone wants to add in? I mean, on this one. Okay. So last overview. In a microservice system, the overview of the microservices can get lost. However, experience teaches that in practice, a sound domain-based division can restrict changes to one or few microservices. Okay, yeah, this is kind of connected to this one. Therefore, the overview of the system is less important, because the interaction between the microservices hardly influences development due to the high degree of independence. Yeah, so that's the cohesive nature. So they say always, like when we try to split the microservices, I think we read it in the first section or somewhere. There is no clear-cut rules that you need to split the microservices in a domain-based or technical-based. But here, I mean, somewhere I read that just make sure if it's more cohesive, then put it in one microservices, which means so that we can avoid this issue. But if there is a reason, definitely we need to go, like, for some technical reason this needs to be auto scaled, then at that time we create a separate microservice. But I think that if we keep it as like a domain based, then I mean all the related changes will be part of one module. So if you really wanted to get that deployed, you are impacting the supporting microservices less. That's the idea I think they are giving here. Anyone wants to add in last overview? Okay. Okay, so
It's a very big topic actually, so it's hard to condense it into a few words. Uh, yeah, maybe we can talk about it later.
okay. So increased latency and failures. So microservices communicate through the network compared to local communication. So the latency is much higher. It is also more likely that communication will fail. A microservice system cannot rely on the availability of other microservices. This makes the system more complex. So yeah, I mean, it's a known fact that because if it's a single process, everything inside the same process, but we are going to keep like as a different process, right? So it has to um, communicate through the network. Yeah, anyone wants to add in? Increase latency and failures. So I'll move on.
Yeah, because they're all deployed in separate VMs, right? So the
Yes,
definitely that affects the latency, and if one is down, definitely the communication will fail. And when you're deploying a microservice to a VM, you don't know whether the other microservices are alive or not, right? You kind of rely. I mean,
that's correct. Yeah.
yeah. So I think that's what they mean.
Okay. Yeah. So weighing benefits and disadvantages. Okay. The most important rule is that microservices should only be used if they represent the simplest solution in a certain scenario. The previously mentioned benefits should outweigh disadvantages resulting from the higher level of complexity for deployment and operation. Choosing a more complex solution is rarely a good idea. So they say that don't go for the complex solution. Is rarely a good idea. Yeah. So finding the right microservice recipe. Yeah, this is the outline that they're giving. So identify the problems, prioritize the benefits, assess potential challenges, identify suitable microservice recipe. Yeah. So when we get into a scenario that we wanted to split monolithic into multiple microservices, this is the idea that what are we going to gain and what is the downside, and then based on that we go with splitting it up. So experiments. The following approach helps us to find the right recipe to divide a system into microservices. Identify the problems in your current system. For example, resilience, development agility, too slow deployment, and so on. And then for the projects that you have worked on, prioritize the benefits of using the microservices. Okay. So yeah, and then weigh which of the challenges in this project could pose a risk, and then look at the possible technical and architectural solutions in the following chapters to determine the most sensible solution for their requirement. So for the concrete division into microservices and for the concrete division into microservices and for technical decisions, additional concepts are necessary. So let's discuss question of how best to divide a system into microservices in the next chapter. Yeah. So here we have kind of a micro and macro architecture, which is coming as part of the next one. So we'll quickly conclude. Suppose you are designing an application where, is it okay to, I think already 11:24?
I'm okay. We can finish the quiz.
Okay.
It's three
Yeah.
questions.
Yeah. Suppose you are designing an application where one microservices gets data from another. If this data fetching fails, the functionality of the app will be compromised. What would be the best course of action in this situation? So basically, we are trying to get a data from one microservices. If this data fetching fails, then the functionality of the app will be compromised. Keep things as they are, merge the two microservices into one, create another microservices that gets data and then pass it on. Anyone wants to add in? I mean, guess.
Yeah, he's saying if the data fetching fails, the functionality is compromised, which means the data fetching cannot fail, right?
Yeah,
So, yeah.
which I think they are functionally cohesive, right? Which means both the functionality should be in one microservice, right?
Yeah, they have to, it's like a transaction. So, likely B, yeah. We can see that answer.
Yeah, microservices communicate over the network, which is unreliable. The app should not depend on this communication. So automated deployment can save considerable effort with microservices.
True.
True, yeah. Microservices should only be tested independently. Testing them together should be avoided.
False.
False, yeah. Oh no.
Oh, okay. Because we do both types of testing, right? We have integration testing where you test one with the other. Oh, maybe he's just considering deployment. But in our case, we do both actually.
Should only be tested independently. Testing them together should be avoided. Otherwise, the deployment is not
Oh,
independent.
you know what? Oh, what he means is the test cases themselves should be independent. It's like, yeah, I think he.
Um, yeah, somebody, I mean, added a note, I think.
Yeah, A makes sense.
Okay.
Yeah.
Yeah. I think that's pretty much. I think, yeah, if it's already 11:27, I think we can maybe okay to read, I think tomorrow from this chapter conclusion and then bring it in macro architecture.
Yeah, it is like conclusion chapter, right? It's fine.
Okay.
Minutes and we can go for macro and micro.
Okay. Then I'll quickly read it. Like chapter conclusion. That anyone wants to quickly read, or is it okay for me to go?
Okay, I can read.
Okay.
This is for oh, one second. That's it for this chapter. Here is a quick summary of what you learned. Microservices represents an extreme type of modularization. Their separate deployment is the foundation for a very strong degree of decoupling. Yes, this results in a numerous advantages. A crucial benefit is isolation at a different level. You want to explain or it's fine just reading?
Yeah, just reading is fine. Yeah.
Yeah.
The same repetition. This not only facilitates deployment but also limits potential failure to individual microservices. Microservices can be individually scaled. Technology decision affects only individual microservices, and security problem can also be restricted to individual microservices. The isolation allows one to more easily develop a microservice system with a large team because it requires less coordination between teams. In addition, smaller deployment artifacts makes continuous delivery easier. Moreover, replacing a legacy system is much easier with microservices because new microservices can supplement the system without the necessary of large code changes in a legacy system. Yeah, I think it's understood, right? Why we are going for a micro services, individual deployment, individual scaling, and if any, I mean, fault tolerance. If you want to do individually, you can attend and continuous delivery. These are the things. The challenges are mostly associated with operation. Appropriate appropriate technological decisions should strengthen the intended benefits, and at the same time they should minimize disadvantage like the complexity in the operation. Yeah, it makes like a, it's not only advantage of making microservices, it should not be the complex also. Of course, integration and communication between microservices is more complex than the calls between modules within a deployment monolith. The added technological complexity represents an additional importance challenge for microservice architecture. Yeah, that we need. Okay.
Yeah. Yeah, I think we are good. So from tomorrow we'll start micro and macro architecture.
Yeah.
Yeah. Thank you everyone.
Thank you.
Thank
Yeah,
you.
thank you all. Bye.